MemPalace, a new open-source AI memory system built by Milla Jovovich and Sigman that just dropped, claiming to wildly outperform standard retrieval-augmented generation. Now, we haven't independently validated their raw benchmark numbers yet, but if you look closely at their open-source code, they are using 4 brilliant architectural patterns that solve the core flaws of traditional vector databases. In this video, we will break down 4 things. First, the problem with current AI memory. Second, the conceptual architecture, the MemPalace hierarchy. Third, how the AAAK Compression Dialect actually works. And finally, the 4-layer logical stack that ties it all together. So first, the problem with modern AI memory, which is Lossy summarization. Standard approaches like Mem0 or ZEP burn paid API tokens to physically summarize your text before storing it. They delete your raw conversation to save space, but in doing so, they destroy the nuance of exactly why you made a decision. Other systems, like LLM Wikis, try to preserve everything in Markdown files. This works great at first, but as your project grows to hundreds of sessions, the accumulated documents eventually exceed the LLM's context window, and you are back to square one. This is where MemPalace introduces its first innovation: verbatim storage, paired with strict spatial metadata. MemPalace refuses to summarize. It stores your conversation exactly as it was typed into ChromaDB. But to prevent searching blindly through the haystack, it forces your data into a strict hierarchy called the MemPalace, based on the ancient Method of Loci. Top-level domains become wings. Subtopics become rooms. Inside each room, there is a closet, which holds the AAAK compressed summary, and a drawer, which holds the verbatim raw text. And when the same topic exists across multiple wings, a tunnel connects those rooms. The closet is the key insight. It acts as a compressed pointer. The AI reads the closet first to understand what is stored, without having to actually load the full drawer. Only when the AI needs the deep context does it open the drawer and pull the verbatim text. Now let us look at the magic behind the closet. This is where the AAAK dialect comes in. AAAK is a custom shorthand that compresses natural language by up to 30x. An 850-token conversation becomes roughly 28 tokens. Here is how it works. Every memory unit, called a zettel, follows a strict format. It encodes entity codes, the core topic, a key verbatim quote, an importance weight, emotional tags, and semantic flags like decision or technical, all packed into one pipe-delimited line. The genius is that no decoder is needed. Any modern LLM, Claude, GPT, Llama, can natively read the shorthand and reconstruct the full meaning. The LLM itself is the free decompressor. Now let us look at the logical stack that ties this all together. MemPalace uses a 4-layer progressive loading system to keep the context window incredibly lean. Layer 0 is identity, just 50 tokens that define the agent's personality, always loaded. Layer 1 is critical facts, encoded in the AAAK dialect, roughly 120 tokens that map the entire palace. Think of it as loading the table of contents without loading the book. This is actually the same pattern used in agent skills, where the name and description of each skill are always loaded, but the full contents are only read when that specific skill is invoked. MemPalace applies this exact lazy loading principle to memory. Layer 2 is the knowledge graph, a lightweight SQLite database tracking relationship facts. Crucially, these facts have a valid from and valid to timestamp. If you changed your database 3 months ago, FlatRag will still fetch the old context. MemPalace's temporal graph resolves the conflict instantly. And Layer 3 is the full verbatim storage in ChromaDB. The AI uses the metadata from Layer 1 to pinpoint a specific wing and room, slicing the vector space into a tiny fragment before running the actual semantic search. And unlike enterprise cloud memory APIs that burn massive amounts of tokens behind the scenes, MemPalace parses ingestion using incredibly fast local regular expressions. The entire ingestion pipeline has a 0-token tax. It is entirely free. MemPalace is certainly not magic, and you do have to maintain your taxonomy manually. But it is undeniable proof that structural metadata filtering layered over a local database can compete with, and potentially beat, pure, unorganized semantic vector search. Structure wins. What do you think about this MemPalace architecture? Can structured metadata replace pure vector search? Let me know your thoughts in the comments below.